Hello everyone, let us study today first order control system. Let us see. So what is first order system? So first order system is what there is only one pole in the system, or the order of equation is one, that is called first order control system. So RC circuit, heater system, level system are example of first order system. So let us study the response of first order system. Before that, let us define the first order system in Matlab. Uh, Basically, this is a live script. So let's see. So first, the gain and time constant. So this is a transfer function of first order system. G of s is equal to k upon s tau plus 1. K is called gain. T is called time constant. S is Laplace transform variable. Okay. So let us run this live script. So I'm going to run section by section instead of this run. So let us do that. So can you see the output? Yeah, 5 upon 2s plus 1, that is my transfer function. If I want, I can change the gain, and based on that you can see. Now you may wonder how to enter this kind of variable in the Matlab. So let me show you the example. Just say d is equal to, I can have an insert, then control, and here I can have a slider. Whenever you add slider, you have to give this 4 value: minimum, maximum, step, and default value. So I know gain I want to give say 1 from say 20, and in step of say 1, and default value should be between minimum and maximum. So that's why it is giving error. So let me have a 2. So I can do that very easily in the live script, right? So let me run again, run section, yeah, and let me change the time constant, and you can see that I have changed the time constant and it is there. Okay, let me yeah, now if I want to plot the time constant, the step response, so how I have plot the step response, how do we define the transfer function? Let me explain that. First, the numerator constant, that is gain, and denominator constant, that is tau and 1. This is where how I define my plant. Now how do I get the step response? So there is a inbuilt function called step, and my system is plant, and I'm running for 10 seconds. So here this is time, this is optional, but you can put it and grid on. Now we know the time constant definition, the time required to reach 63.5% of final value. So I'm just putting some y line at 63.4% just to have idea what is the time constant, right? So let's see these things. Here is the response. So can you see that at almost t is equal to 3, it is reaching to 63.2%, 63.2%. So it is called t is equal to 3, that is time constant that we have verified, right? Now what you can do, you can study different you can change different value, and you can just study the effect of different parameter, and you can play with this time constant as well. Okay, another thing that I have done, that I have plotted time domain response. So if you do the inverse Laplace, the time domain response is given by k into bracket 1 minus e raised to minus t by tau. So I've written CLC clear all t from changing from 0 to 10 in a step of 0.1. Tau is equal to 4, that I have taken some value, and k is equal to 10, and I have write output is equal to k into 1 exponential of same equation. For e it is exponential, and I have plotted x-axis, that is t, y-axis, that is output. So I have plotted that, and you can see results are here, right? So this is way you can study first order control system in the Matlab. And thank you so much. If you have any question, let me know. Thank you.